Alright, so on this question, the first thing you have to address are the negative exponents. So when you have a negative exponent in the numerator and you want to make it a positive exponent, you're going to have to bring it to the denominator. Now keep in mind that each of these terms are technically over 1, which means that when I flip them, it's going to become 1 over h plus 5 minus 1 over 3. Okay? Then we're going to multiply the opposite fractions by the opposite denominator to get them to have a common denominator, since they don't have any factors in common. So this is going to become 3 minus h minus 5, because remember you have to distribute that negative sign, all over the new denominator of 3 times h plus 5. So then this right here is going to get combined, and this is going to become negative h, 3 minus 5, minus 2, all over 3 times h plus 5. So that's our new numerator. And then as for the denominator, it's technically over 1. So do you remember keep, change, flip? Mm-hmm. So this is going to be times 1 over h plus 2. Now we're going to go ahead and factor out the negative here and here. We end up with negative h plus 2 over 3 times h plus 5. Times 1 over h plus 2. Now we're going to cancel out here and here. And this is going to become negative 1 over 3 times h plus 5. Now we're going to go ahead and plug in negative 2. So this is going to become, we're going to plug in the negative 2, so this is going to become 3 times negative 2 plus 5. So this gives me negative 1 over, this becomes a 3, 3 times 3 is 9. Alright, any questions about this one in particular? Alright, let's go ahead and move on. Alright, so the next question is, now we're going to be looking at limits, left-hand, right-hand limits in a piecewise function. So I went ahead and graphed this ahead of time so we can take a look at the graph so you can get a visual of what's happening here. Okay, so this is the visual of the graph for all the piecewise, the pieces of the function. So if we're looking at 0 from the positive side, approaching from the right, okay, if we're approaching from the right, we approach the value of 1, right? Mm-hmm. So mathematically speaking, we would plug 0 into this equation. That would be negative 0 plus 1, which would just be 1. So that's how you get it mathematically compared to the graph. Okay? So then, for the next one, we're looking at negative 1 from the left side, right? Because it's a negative sign. So if we look at the graph, we're looking at 1 from the left. If we're approaching from the left, we're approaching what value? 0. So the answer is 0. But had you not done it that way, you would have plugged it into this equation. And the reason you would have plugged into that equation as opposed to the second one, even though it says x is equal to possibly 1 versus this one that doesn't have the equal to, you're going to plug into this one because we're looking at it from the left side. And that interval comes first and includes 1. Because remember, evaluating limits is not the same as evaluating functions at a point. So next one we're going to look at it approaching from the right. So if we approach 1 from the right, as you can see, we approach at the value of 1, right? Okay. And that would be us using this interval. Thank you. And then we want to look at if these two limits match, so the left and right hand limit, which means that that's possible whether or not this whole limit exists. Yeah, you're in my 3rd period. Yeah, this 4th. Here, you want your hero pass back?
Thank you.
I was so confused for a second. I'm like, I thought you were in my other class.
Wait, so I missed it?
You missed my class.
Oh, I bet.
So did the left and right hand limits match here? No, so does the limit exist? Okay. Alright, so for the next one, I have approaching from the left side, which is at 1, right? Because of this interval. And then approaching from the right side, we're not going to include this portion because this is just a point discontinuity in the graph. If you look at the graph here, you see this point discontinuity, but you see how the limit actually does exist at 2 on both sides, and they match up at the same value of 1. So these are both 1, which means that the limit does exist, and it is also 1. Now we're looking to evaluate the function at that point. So is evaluating a limit and a function the same? No, because with a limit, we don't care if that point actually exists. The point doesn't exist here, but at 2. Alright, and for the next one, we're approaching from the negative side here. So if we're approaching from the negative side, we're going to use the lower end of the interval with 3. That's going to be 3 minus 1, which is just 2. Then we have the same thing over here, which is just also 2. So since the limits match, does the whole limit exist? And it's 2. And then lastly, 4 from the negative side, we're going to plug into this one here, which gives me 1. So what I want you all to do right now for the next few minutes, go ahead and try example 5B. I'm going to pause it, and you guys can try it.